Hey dear viewers, this is tutorial part 2 for composite structure design with composite column, composite beam, composite deck slab in CSI ETABS software. This tutorial part mainly focus on how to assign and combine all possible loads in composite structure. Watch up to the end to master structural designs of composite structure. As a tip, you will get lesson on how to assign wind load using cladding. Tutorial part 3 will continue, which is all about analysis and designs of composite structure. Now it's time for subscribe to get next updates, like this video, support the channel, and finally drop comments with your question or what you want to see next. Thank you family. Let's start today's tutorial. Before starting today's tutorial, I will attach a video link here in the description box and that of the first comments of this video. That is all about how to define all load patterns or load cases and how to assign or how to combine all possible load combinations, including that of vertical and horizontal loads. Check it. Let's go to the define menu here. So from the define menu, the load pattern. So all possible load pattern is defined like this, and let's check the load combination again. So go to define again, load combination. All load combination is defined like this. This is 42 load combination for static analysis and 32 load combination for dynamic analysis. One combination has its own 4 combination inside. So this is all about. Go back and check the video link. Make it okay. Let's proceed to draw the cladding that helps or that enables us to assign all wind loads in X and Y direction. To draw the cladding, let's go to the draw menu here. From this auto draw cladding, you can use all this choice, but let's use the default one, that is use floors. So click on OK. The cladding is drawn like this. By using this cladding, we can assign wind load in X and Y direction. So to do this, let's cancel this floor plan. After that, let's go to the select menu here. Select by property, frame sections. So let's select all composite beams. Press the Ctrl key on your keyboard, select the main beam, that is the exterior beam, and the interior beam. After that, select, close, right click here, hide a selected object for more visualization. Look at here, the red line indicates that the X direction, so the X direction is toward this, and that of the green line indicates the Y direction. So we can assign wind pressure in Y direction toward this direction, and the Y direction toward this direction, that means. So let's make on the local axis to know more about the directions of the wind. So go to the set display option here from this object assessment. So let's select the local axis here. Make it okay. So the local axis is indicated like this. Let's zoom it the local axis direction. So from this, the local axis direction is towards the inside in this direction, and at the back it is outside this direction, and you can simply assign using this principle. So let's select all the cladding in X direction. After selecting all the cladding in X direction, let's go to the assign menu here. From this shell load, wind pressure coefficient. So wind index, let's first assign the windward direction. So the local axis direction, that is the blue line, is towards this face. So we can assign it as positive. So let's make it positive 0.8 wind coefficient in windward direction. You can calculate it by yourself. So let's make it okay. This is the assigned load in the X direction, that is windward. Let's go back to the leeward direction, that is in X direction again. So let's rotate it. After that, let's select all the cladding. After select all the cladding in the leeward direction, and let's go to the assign menu again. From this shell load, let's go to a wind pressure coefficient here. From this, let's change the wind coefficient value to the negative direction. Let's use 0.5 and make it negative, since the direction of the local axis is from this face. So to make it the suction or the internal pressure, you have to make it negative. After that, click on leeward or side or constant here. After that, make it okay. So both the leeward and windward direction of X is defined like this. You can define all the wind in Y direction by yourself. Don't forget subscribe this channel, like this video, and drop your comment. That may be your question or your suggestion for my next video. Thank you for doing this. Let's proceed to off the local axis and then all the vertical loads that is on the beam and the deck slab. So to do this, let's go to the set display option here. From this, let's cancel first the local axis, make it okay. After that, let's make it into a window. So let's add a window. From this, let's change it to plane. So it's on all story, that is good. Let's go to the select menu here. Select by property from this frame section. Let's select the exterior beam. So select it, make it okay. After that, go to the align menu here, frame loads, distributed. So make it partition wall load. PL is for partition wall load. So from this, let's add a partition wall load of 10 kilonewton for the exterior beams. Let's make it okay. So 10 kilonewton load is assigned to all the exterior beams like this. So let's go to the interior beam one. So select again, select by property frame. So IP 600 is the interior beam. So select it, make it okay. Go to then again, frame loads, distributed. Add or we can assign 8 kilonewton. You can calculate it by yourself. So make it okay. So for all the interior beams, I'm going to assign 8 kilonewton loads. Let's proceed to that of the deck slab. So for the deck slab, we are going to assign partition wall load and floor finish load plus live load. So to do this, let's go to the select menu again. Select by property. So from this, let's select deck section, deck 80. That means select it. Go to the assign menu, shell uniform. Let's go to assign partition wall load of 2 kilonewton. Make it okay. Go to previous select again here. So let's assign it, shell uniform. So let's change it to floor finish. From this, let's assign 1.7 kilonewton per meter square floor finish. Make it okay. From this, let's go to the assign menu, shell load uniform. Let's change it to live load. So let's assign 2 kilonewton live load for this project. So let's make it okay. All of you must give attention here that we are going to assign all these secondary beams as steel section beam. So it must be designed as a composite beam. So all of you must check this. To do this, click on this beam, then right click here. After that, let's check the design. From this, the design procedure is a composite beam design. That is good. Before assigning this deck slab, it says steel section design. Don't forget subscribe this channel, like this video, and drop your comment. That may be your question or your suggestion for my next video. Thank you for doing this. This is all about tutorial part 2. Next tutorial, that is tutorial part 3, we will discuss all about analysis and design plus detailing. See you there. Goodbye. Have a nice time.